This first problem, these are the most frequently missed problems on the exam that I thought I'd go over. If you have questions on other ones that I didn't go over, feel free to email me. But of course, you can see all the solutions right now from that exam. So this question is about the coefficient of friction that is required to keep an object from sliding down a ramp. And that is always going to be the inverse tangent of the ramp angle. So for an angle of 45 degrees, coefficient of friction of 1. If you took the inverse tangent of 45 degrees, you'd get a value of 1. That's the coefficient of static friction that would be required to keep the object stationary. That's the threshold value. Anything below that, the object would slide. Anything that or greater, the object would stay there. So the second question here, a block is on a ramp and it is stationary. And there is friction acting. And what the question in this case is, what is the value of the static friction force? Now it's tempting to use the equation that you might have seen, that the force of static friction you might have seen is equal to mu s mg cosine theta, but that's really the maximum force due to static friction. It's not actually just the force, that's the maximum force. And it's only going to get that much when the ramp is at the maximum angle that friction can hold the block back at. When the ramp is at a lower angle than that, static friction won't be as big. It'll only be as big as the force that's trying to push the object down the ramp or pull the object down the ramp, which in this case is the force of gravity acting down the ramp, which is Fg sine theta. And if you calculate Fg sine theta, that's mg times sine theta, or mg times 30 degrees, sine of 30 degrees, which is mg times a half, or about 4.9 newtons, since the mass is just 1 kilogram. Next problem here, I gave you two vectors here. A 6 kilometer vector west, which you can see there, and an 8 kilometer vector south. And I ask, what is the magnitude and direction of the vector that can be drawn for the initial to the final position? In order to find the magnitude, you take the square root of the sum of the squares of 6 and 8, and that's square root of 100. And so it's a 10 kilometer vector. That's how long the red arrow is there. And the angle I drew there is an angle that you can calculate. And if you found that one, you take the inverse tangent of the opposite side, which is 8 kilometers, divided by the adjacent side, which is 6 kilometers. And that inverse tangent is 53.1 degrees. And that would be, so it's about 53 degrees. That would be considered south of west. So that's the answer to that one. This question here, a block is on a ramp and the ramp is raised until the block starts to slide. We're assuming, of course, that friction is acting, and that keeps the block from sliding until it reaches the right angle. And what motion will the block now experience? Well, if the block starts to slide and you don't change the angle, it's going to keep sliding, and kinetic friction takes over, so it's going to accelerate down the ramp. It's not going to move at a constant velocity. It's actually going to accelerate because the force due to static friction, kinetic friction is going to be less than the force due to gravity. It won't accelerate as greatly as it would if there were no friction, but it still will accelerate. And we actually have an equation for that acceleration for a block sliding down a ramp in the presence of kinetic friction. If you look through your notes, you'll find that. Okay, this question here, consider a block on a ramp, and let me raise the size of this. So for this question, we ask what happens to the normal force as the ramp angle increases. And as the ramp angle increases, the ramp goes from this to that. The normal force, of course, is the force that the ramp exerts on the block. So if this is the block here, what's the force the ramp is exerting on the block? It's greatest when the ramp is flat. It's least when the ramp is vertical. So Fn decreases as the ramp angle increases. It's 0 here. It's maximum here. It's 0 there. So decreases as the ramp angle increases. So in this problem here, a 2 kilogram block is resting on a flat surface, and there is a static coefficient of friction between the block and the surface. But if there's no force applied to the block, there will be no friction force acting on it. So this is an easy question to get wrong, because you got to remember that the static friction force is only going to push back as hard as whatever force else is pushing on the block. And there is none here, so there'll be zero static friction force. And those are all the problems that I will go over right now. If you have other questions, of course, feel free to email me about exam 3.